Today we'll be solving for torque using cross product. So torque is represented as the tau symbol, and torque is the r vector crossed with the force vector. So if you were to draw a door, let's say, and the door hinge is right over here, the force vector would be just any force being applied onto the door with the direction and magnitude given by the vector. And the r vector is just the direction and magnitude from the axis of rotation. So it doesn't always have to be a door, but using common sense, this torque here will be, I guess, larger. The magnitude of the torque will be larger if your r vector is longer or if you applied more force. Well, obviously, if you apply more force, the torque will be higher. But if you apply the force closer, so if you apply the force here maybe, and the r vector is here, the magnitude of the torque will be lower. And like literally try pushing on a door close to the hinge, and you're going to see how much harder it is than just pushing it at the end. So let's solve some practice problems. Let's say that you're applying a force at 340 newtons, and you are, say, 210 meters away from the axis of rotation. You're applying it at that point. Go ahead and solve for this. So to solve for this, all you have to do is find the cross product between the r and the f. So let's go ahead and do that. Now remember, the order matters. So whenever you're solving for cross products, the order of the formula matters, or else you're just going to get every single value but opposite. So let's do r. Let's go I hat, j hat, and k hat. You don't have to set it up like this, but I just like setting it up like this because the visual is easier. 340. So this is the force vector down here, and this is the r vector up here. Let's go ahead and solve for this. 1 times 0 is 0. 4 times 0 is 0. So 0 minus 0 is 0. We have 0 times 3, which is 0, minus 2 times 0, which is still 0. And we have 2 times 4, 8 minus 3. So the torque is given by the vector 0, 0, 5. So this is tau. Let's move on to the next problem. Let's say the force is applied at the point 1. Actually, let's say that the force is 0.5, -2 newtons, and the distance, or the vector that represents the point at which you're applying the force to, is this down here. Go ahead and solve for this. So again, I'm going to set it up with the I hat and the I hat and j. Why is my writing slanted right now? I hat, j hat, and k hat. 1, -3, 4, 0, 5, 2. And we're going to solve for the cross product between r and f. So this is r up here, and this is f up here, down here. Let's go -6 minus 20, comma 4 times 0 is 0. 1 times 2 is 2. And the last part is going to be 5 minus 0. Because we multiplied 1 by 1 and 5 here, and 0, -3. You get 0. So this right here is going to be the, -26, -2, and 5. This is going to be the torque vector for these points of force and place where you applied the force to on the or distance from the axis of rotation right over here, given by the r vector. Okay, solve for one last one. Let's say that you apply the force of 5 -3.2 newtons, and then you apply it at point 2, 4, -1, 2, and 4. Last one, just go ahead and solve this. Literally, this is all just cross product practice. I'm not even gonna lie, it's just interpretation. You just have to know what variables to use, and just doing the cross product at the end of this. And then, let's say for this, solve for the magnitude of torque here. So, set this up. K, J, -1, 2, and 4. 5, -3, and 2. This is the r vector, and this is the force vector. Solve for the cross product between them. 4 minus, or actually plus 12. 20 plus 2. And 3 minus 10. That gives us tau vector 16, 22, and -7. So this is going to be the vector for torque, but let's go ahead and solve for the magnitude here. Let's do the magnitude of tau is equal to the square root of 16 squared plus 22 squared plus 7 squared. Okay, I'm gonna have to use my calculator for this. That 2 gotta be next to here. I'm gonna have to use my calculator. 16 squared plus 22 squared plus 7 squared. There you go. Turns out to be around 28.089 for the torque. So that's it for the video. It's a pretty quick one because torque is just more cross product practice. All you have to know is where and when to use the r vector and the f vector. And typically the f vector is going to be represented with n, because force's unit is newtons, and distance unit is meters. So if you have any questions, put it down in the comment section.